Welcome to our channel Electronics on Wheel and thank you for your support. Please like, subscribe and comment if you like the content of this channel. And please have a target of 50 likes and 50 comments on this particular video if you like this content of this video. So we are starting with the second topic in this particular series. So that is the charging type. In the first chapter we have discussed about the electric vehicle architecture, where we have discussed about all the components and what are their functions. Now in this series we will go one by one into the particular topic and we'll try to understand in the detail. So first we'll start with the charging type. So there are two types of charging. First is the AC charging and second is the DC charging. So what does it mean, the AC charging and DC charging? So we already know that we have the lithium battery as a power source in our vehicle. So we need to charge this particular battery to get the power supply, right? So to charge that particular battery, you know that DC is the input for this particular battery, where you have inside this you might be having BMS and all those things that we will discuss later. But DC is the input to charge this particular battery. So you have the electric grids from where you will get the AC supply. Then you will be having your charging stations, where in charging stations you will get the AC. And in this vehicle itself, till this point, charging point, this input, you are getting the AC. So there are two ways to get the DC. First is that you have the onboard charger, which is converting your AC to DC inside the vehicle. This is the first way. Second thing, you can do one more thing. You are getting the AC current from the these grids. Then you have your DC charger outside the vehicle. So this particular grid or DC charging station is taking the AC, and then this on-board charger we have kept outside. You can say off-board charger also we say off-board charger, where AC to DC is converted and we are directly feeding the DC to our vehicle and directly it is going to the battery. So this is the difference between AC charging and DC charging. This called as onboard charger, where you are putting the onboard charger inside the vehicle and it is converting AC to DC. Second option, you are putting this particular charger outside where AC to DC is converted outside and we call it off-board charger, and you are directly feeding to the DC, to the battery. So this is the DC charging and this is the AC charging. But what are the challenge between this AC charging and DC charging? We will try to see. So here you can see this is the same thing what we have discussed, that EV on board charger which convert the power into the DC and charge the battery. In DC, the power is converted outside the vehicle, okay, in charging station, and which then supplies to DC power directly to the EV batteries. This is called fast charging and AC charging is called as slow charging. We will try to understand this also, why AC charging is slow charging and DC charging is the fast charging. So let's understand this thing. So faster you want to charge the battery, more power you need, right? Fast charging is usually above 50 kilowatt. Above 50 kilowatt, if you are doing taking the power, then it is called as fast charging. Slow charging is typically between 1 to 22 kilowatt. To provide the more power when you are charging the battery, you need much larger AC to DC converter. Suppose if you need more than 50 kilowatt, then AC to DC converter also you need the larger. As in previous videos also we have discussed, if your component is handling more power, then that particular component would be bulky and expensive, right? So that is the concept in the power handling. If even if you see the switches in your household, some normal switches which are used for the fan, controlling the fan, it the size would be very normal size. But when you are taking some of the switches which are used for the geyser or some other function, you will be seeing those sizes of those switches would be larger, and that is the reason that you are going to handle the more current in the geyser but for the fan and other normal appliances, you need only normal current, right? So that's why they are small in the size, but geyser switches are bigger in the size. That is the one thing. The problem is converting the high power from the AC to DC. AC to DC is expensive. That is, as I told you, that it will be expensive because the component will take more space. It would be bulky, and of course the cost will be high. This high power charging is best carried out with the converters built into the charging station rather than into the vehicles. So you are not going to dragging around the heavy and expensive converter dragged around with you in your car. What does it mean? So suppose if you say that okay, onboard charger is the problem, right? Because of onboard charger, we have this limitation of slow charging and fast charging, right? So when suppose if you are going to put this whole thing inside your vehicle, then your vehicle become heavier, right? And if your vehicle become heavier, then it is very difficult to take all the weight, in your journey, when you are traveling. It would be very difficult, and the efficiency and range, everything will go down, right? So this is the also one reason that DC charge, you cannot make this onboard charger more bigger. Okay, so suppose right now we are using till maximum 22 kilowatt. You cannot say that okay, I will make the 50 kilowatt onboard charger inside the vehicle. If you are making, then what will be the disadvantage? It will be heavier and expensive. If it is heavier, then your EV range will automatically come down. I hope you understand this thing. So DC charger are cost a lot more than AC charger, as we have already discussed. DC charger require more space, definitely, and require much more complex spare parts such as active cooling. So whenever you are increasing your, you know, uh, fast charging or the power delivered to the vehicle, then what happens? You need the active cooling, okay, to function that particular unit properly. If you don't have the liquid cooling or active cooling to that particular component, it won't properly work because it will get heat up during that particular charging of the vehicle. So that's why active cooling or liquid cooling, you can say, there are different cooling is there. So we can discuss those points later. But as of now, you just understand, when you require more power, more heat will produce, and more heat will produce, then you require the cooling for that particular component. Then this is the same thing which we already discussed, that high power charging requires high power connection to the grid also. With a typical residential rigid grid connection, you won't be able to install the DC charger. So DC charger are specifically made on the highways. You will not get those DC chargers everywhere. They will be on particular location, uh, because they require that particular high power connection from the grid. You cannot install the DC charger in your home. This also need to be understand, because first thing that they are expensive, and second thing they need high power connection. You need to keep the transformer and all those things to step up and step down your power. The main advantage of AC station is that they are affordable. They are cheaper than the DC charging station 10 times with the same performance. You can't say same performance because this AC charger are the slow charger, right? So same performance we cannot say. You need the more time. However, uh, the now the AC charging stations are also coming with the high power delivery. Like as I told you, like 22 kilowatt is already in the market, but uh, the OEMs are working on this particular aspect, and they are going to increase till 50 kilowatt as well, or 42 kilowatt as well. So let's see. But this is the disadvantage of AC charging station, that they are slower. Then coming to one aspect, like how you can say, like suppose your AC charging station can provide 22 kilowatt of charging power. We take one example. And if you have your battery of capacity of 20 kilowatt, then it can be fully charged about an hour, right? But if your onboard charger, this particular charger, is only 3.7 kilowatt, your charging station can deliver 22 kilowatt. What does it mean? That your vehicle is not able to take this 22 kilowatt per hour, right? This can take only 3.7 kilowatt, right? So you can divide 22 by 3.7, then you will get around 4 to 5 hours, right? 5 to 6 hours it will take to charge, right? So this is the drawback also of AC charging. When you have the onboard charger, it all depends on your vehicle, that how much capacity of onboard charger you have in your vehicle. If it is 3.7 kilowatt and your charging station can deliver 22 kilowatt or 50 kilowatts or whatever, okay, more than this, then your vehicle will not able to accept. Your vehicle will only accept 3.7 kilowatt. That is also one challenge in the AC charging. However, in DC charging, this is not the challenge. In DC charging, only your battery, battery peak charging is there. So, if your peak current of the battery is good enough to handle the 100 kilowatt or 200 kilowatt, then it is fine. We will discuss about this thing also, that how much your battery can accept in the DC. So in that also the similar type of case will come, that your battery will not be able to handle uh, you know uh, uh, to the beyond that particular limit. Beyond that particular limit, your battery will not be able to handle. So this type of situation will come in the DC charging also. But in AC charging, this is the limitation which we have discussed, that onboard charger rating if 3.7 kilowatt, then it won't be able to take it. Then we will try to understand the different modes in the electric vehicle. So you might have heard that mode 1, mode 2, mode 3, mode 4. So what are the meanings of mode? So mode meaning means that how your electric vehicle is going to connect with the grid. So mode 1, what it says, if you are directly connected to the standard socket outlet, that means that it is a mode 1. But what is the challenge in this particular mode? That you do not have any control or communication. So you do not have any safety protection in this. So most of the country, this particular mode 1 is banned for the EV vehicles. Then Mode 2 is a standard socket outlet, but with this particular box, and this particular box we call it ICCB box or ACEV charger. ACEV charger is nothing but it has the control and communication. So during the some mishappening is happening, during the charging is happening, then it will detect that particular fault and it will disconnect your power supply from the AC outlet. Okay, so this type of control communication you will be having, and this is a movable part. You can take this particular part from one point to other point, and this is allowed in most of the country. You can take this particular charger from one station to other station, or one point to other station. This is a movable, this is just a box, it's not a problem, but it has some limitation. That is the challenge. We will see those limitations, what are the limitations in the charging. Then third type of mode, that is mode 3, that is a permanently connected to AC supply network. So these are the AC charging stations which we have discussed, and they can deliver till 22 kilowatt. Okay, where you will be having the control and communication, and already this particular charging cable would be attached to this particular AC station. However, you can take out this particular charging station separately with you can take with your vehicle also. So this particular facility you will be having, that you can take this charging cord uh, with you also, but most of the AC charging station will be having this attached cable, and you have to just put this charging cord into your vehicle. But here you have to have this particular charging cable with you all the time. Then we have the third mode. So mode 1, 2, 3 are related to the AC charging, and mode 4 is for the DC charging. So you will be having your DC charging station where AC to DC will be converted, and this cable will be connected to the your vehicle as a charger. Okay, so here you will be having the control and communication, both the things. And if someone is saying mode 4 charging means the DC charging. If someone is saying mode 2 or mode 3 charging, that means the AC charging. So here, as I told in this case also, like charging cable, there would be two cases. Like charging cable, you might also can carry, or charging cable will be with the is this AC charging station. But here, this DC charging station, this would be a permanent part of this particular charging station, DC charging station. You cannot carry this DC charging cable with yourself. So I hope you are clear with the modes, what is the meaning of mode and how they are defined. So let's understand the different levels in the electric vehicle. So there are different levels: AC level 1, AC level 2, then DC fast charging. DC fast charging is nothing but the level 3. So level means how much power can be delivered to the vehicle. So right now I am talking about the USA, North America. So there are first level, AC level first, where we have the voltage input, that is 120 volt for one phase AC, and you can get the 12 to 16 amps of current. So if you see the charging load, that can be maximum 1.9 kilowatt. So to calculate this particular charging load, you have to just 120 into 16 amps, that would give you around 1.9 kilowatt. So as I told you, for the USA you can calculate for the India and Europe also, but for the single phase you don't get 120 volt, you get 230 volt in the single phase for the Europe and India. So that similarly you can calculate this particular value, that how much can be in can be the charging load in the case of 230 volt. Then coming to the AC level 2, in AC level 2 also in USA you will get the single phase only. In single phase you will be having the 240 volt and 208 volt, and this particular voltage comes in the for the residential, for the commercial purpose, where you need the high power demand. So in that your amps can go to 80 amps maximum, and typically 32 amps we use. But if I calculate the charging load, then you can calculate like 240 into 80 amps, so you will get this particular 19.2 kilowatt. So this is the maximum value which you can take from the charging station. So this is what we define in the level, how much power can be delivered to the vehicle. So similarly for the India and Europe, you can calculate for the three phase also in level 2. And charging time, it depends on the vehicle to vehicle, so I will not go in this particular what is the charging time. However, we will see the typical value of the charging the vehicle, but not now. In the upcoming videos we can see those things. Then we have the DC fast charging, which is called level 3 as well. So in this you can get as a input from the grid 208 or 480 volt in three phase AC. But in DC fast charging you are not getting this 480 volt three phase here on your vehicle. This particular station is getting this particular voltage and this particular amps. What you are getting? You are getting directly DC here. And already we have discussed that you can get this particular value till 350 kilowatt. 1000 volt DC you can get, 500 amps till 500 amps you can get. So these are still in the development phase, but I think around 400 amps and this 1000 volt DC is already available in the USA. So you can get this much of value from the your DC charging station till 350 or 400 kilowatt you can take from the charging station, DC fast charging station. And this is the reason that your DC charging is fast, because you can take more power from the DC charging station. If you see the AC charging level 1 and level 2, this is the maximum 19.2 kilowatt in the case of AC charging or AC charging station. So 19.2 kilowatt only you can take from the AC charging station maximum. But in case of DC fast charging, you can take till 350 kilowatt or 400 kilowatt as well. So this is the reason. If you talk about Europe or India, 230 is the single phase value, and uh, you can take till 16 amps or 32 amps. Till 32 amps you can take. So you can calculate this will come around 22 kilowatt. So in the India or Europe, you can take maximum power around 22 kilowatt only. So this is the reason of AC charging as a slow charging and DC charging as a fast charging. And that DC charging has some limitation which we have already discussed in the previous slides. Now moving to the types. So we have discussed modes, then level, then coming to the third one, that is the type. Type means that what type of charger or vehicle interface you have. So we have the different around 4 to 5 types of charger. So here you can see in North America and in Japan we have the 5-pin charger, where 3 pins we are using for the power and 2 pins for the signals. We will discuss in detail what are those 2 pins and why we are using, what is their function in detail. But as of now, you just understand what we are using in North America and Japan as a plug name J1772 type 1 also we say. In EU and rest of the market, we say type 2, and this is the standard IEC 621962, where you will be having. So, as I told earlier, also this only support single phase, but in the case of this supports single phase plus 3 phase as well, because in Europe you will be having this 3 phase also and a single phase also. So here you will be having two more extra pins. You have here these 3 pins, but here you will be having the two more pins. Okay, those two more pins are added for the 3 phase. Then you have the charger, China. In China, we have the GB by T type of plug name, which is similar if you see from the European market. They have just changed few things. In detail, we can go in the next video, but you can see the structure is somewhat similar. Now coming to the one more charger, that is the charger provided by the Tesla for all the market except EU. In EU, they use the adapter to charge the vehicle. So this is the type of charger which Tesla uses for the AC and DC charging both. So they do not have the different charger for the AC and DC. They use the same charger for the DC and AC. And India, you know that we use the type 2 charger for the AC. And if you see here, we have the different type of vehicles. So we use the Chadamo also. We will see this first, and let me first go to the. So we have seen the AC charger. Now we will see the DC charger. In DC charger, so similarly, this is the integration or CCS1 or CCS2. These are nothing but just a integration of type 1 plus these two pins, if you see here. So this is the combined charger, AC plus DC. Here also if you see, this is the type 2 charger and plus these two DC pins. So DC plus, DC minus, PP, CP, L1, L2, L3 and N. We will discuss these, what is the function of all these pins. Then we have the GB by T for the DC charging. If you see in the case of Japan, so we have totally different charger for DC, that is called CHAdeMO, and this is going to be obsolete because they are also going to adapt this CCS2. Most of the countries are going to adopt this CCS2 in the coming years. So if you talk about the India, so in India we have the different vehicles. So all are using their own charger. So however, CCS2 is most acceptable. Others also are used like CHAdeMO and this GB by T. So in the AC charging, we have discussed what is the AC charging, DC charging, what is the difference between AC and charging. Then we have discussed about the levels, modes, and the types. In upcoming video, we will go more in the detail in the mathematics